In this video, we will look at creating embedding space. As usual, we start loading the packages that we will use in our notebook. Now we read the data, sampling only 50,000 rows. Let's take a quick look at the data. We notice that we have comment body. We already used it in the previous section. On the right, we have new desk, which is a column on which we will train the classifier. If we take a look at the unique values of this column, we notice that this reflects the topic or categories that comment body is about. We have culture, magazine, travel, sports, dining, and so on. The number of classes of the classifier is exactly the number of unique values of this column. Again, a key step is to label and code the target variable from text to number. We have text, we want a number. This time, the number of topics equals the number of classes. And we're back to text processing. Let's make all the steps. Then we assign the maximum number of words to 5,000 and the maximum length to 100. Then we tokenize and fit on text. And now we have a fundamental tip. How do we get word names for each index after tokenization? We have the method wordIndex. Let's implement it. Wow, we see that the index 0 is missing. Why? Because it is reserved to the padding word. Remember the 0 in the padding step? This is the vocabulary size. But we need to add 1 because, as we mentioned, we have the padding value. We now create sequences and execute pad, split between train and test. And finally, this is the dimension of the embedding space. The higher, the better the clusters, but bigger the data. It's a trade-off. You choose. Okay, now it's time to write down the model. We see that we have the same structure that we had in the language classifier. And as a first layer, we have an embedding. As a second layer, a flattened layer. And finally, a dense layer that will output 28 probabilities, 1 for each topic. Let's compile the model and let's print the architecture. Now, finally, we feed the model and we use 3 epochs. Okay, the training is finished, but now we have another nice tip for you. How do we get the embedding matrix weights? We have the getWeights method. Let's implement it. Okay, we have the model, we have the layer. Remember, we want the first layer, the embedding, because we are doing word clusters. And then we get the weights. We can see that this is a 3D NumPy array and we need to reshape it. Since TensorBoard works with tab-separated CSV files, we transform our data into pandas and then print it. Very important. Remember that when you tokenize, you reserve index 0 for the padding. So the 0 row, data 0, represents the padding coordinates. So we need to skip it. For each row, we need to know which word is represented in order to understand better our clusters. Here we have the length of the metadata and the length of the word index. We do some simple processing and then we print the metadata, that is, the word labels. Okay, at this point we have to go to TensorBoard. In the next video, we will look at visualize the words with TensorBoard.